Well,
Oh, there we go.
we're recording on our side, I'm sure.
Sure. Yeah, if you could just share that afterwards, just to
Okay.
have something to reference in case I missed something.
Okay. All right, so because we're just starting the recording, I'll just quickly go over a couple of points again. This is the second part we're looking at. For this part, this 0.15 millimeter fillet radius turns us into a very very interesting 3D mill on the top, which just takes a lot of minutes
Sure.
in a CNC. So we can get rid of that fillet and replace it with a tumble deburr, which would smooth out the whole part, get rid of a lot of the mill marks, and give you a nice small radius around everything. I think you'd be very pleased with that. We can't mill a fillet up against a flat edge like this. We need fillet radiuses in there. We need a fillet radius on this corner and this corner. These fillet radiuses will translate to the size of the end mill we use to mill this. So the larger the radius, the better. The rest of this part is fairly straightforward and doable. We just need unspecified inside corner radii and maximum break edge specifications. Going back to the 081 part real quick. All right, that would be this part here. To mill that, with this being an included angle less than 90, this becomes a very difficult thing to mill. Can be done, but not easily.
Understandable.
Getting rid of that sharp corner there, putting as large a radius as possible is helpful. These corner radiuses in the pocket are only 0.5 millimeters or 20 thousandths, and that determines the size of the end mill I have to use. It would be beneficial if we can get all inside corner radius of milled pockets as large as possible. Remove sharp edges, how much?
Sure.
The specification and unspecified inside corner radii, because all end mills will have some sort of radius on the corner. So that brings us up to where we are right now. The third part, we'll do this one first, which is actually an assembly.
Yes.
And this is an assembly of two different parts. And in this part, once again, this corner radii being only 14 thousandths means I have to use a 28 thousandths diameter end mill. And an 028 is basically a 0.7 millimeter end mill for a depth of 5.14 millimeters. That would be nearly impossible to make. The end mill would break before I can mill that out. So whatever we can do to get this as a larger end mill, or I could end mill it from the side using like a ball end mill, but then I would need a radius at the bottom. That would cover it. Same thing here. This radius is larger. This one being 0.8 millimeters, but it's still a very long way to send an end mill to give you that radius. And the deflection on the end mill would be very great. It's just too deep of a mark. This inside corner radius, I believe, is 20, or no, it's 13.7. So that's a 0.35 millimeter as well. Once again, I can do it, but it's going to take a lot of minutes to mill that out. It'd be better if I can get larger corner radii there. You can see there's a theme going on here about corner radii.
Yeah, of course.
There's something here. There's like two different diameters on the tip of this. I have to have it inside corner radius, the minimum being 8 thousandths. And 8 thousandths, 25.4 times is 0.2 or 0.21 millimeters. So that I would need a minimum of that for the unspecified inside corner radii. But just note that you're going to get that. I think this is just a clearance cut to reduce whatever is making contact with it, in which case the fillet radiuses in the corner probably won't bother you. And you can go as large as you want.
Because it's more of, there's a cap that kind of goes on top of this, so it's I'm pretty sure it is to do with that.
Right.
I'll see what tolerances we
It
have.
was either clearance for something, or you're gonna put a label on this, and this is a clearance pocket for a label.
Yeah, no, there's no label. There's a plastic cover that kind of sits on this. That's the part that actually goes into the mount.
So we just need some radiuses in the corners. We
Sure.
can't turn it dead sharp. The other portion, well, not that one, this one. The other portion of this, I got the exact same comments again.
Sure.
What's interesting is these countersinks cannot be put in directly from the top. They
Yeah,
can
so-
be put in with a special tool because this is tapered and you do have a gap. So
Mhm.
I could make a special tool that would go,
Wow.
in near the bottom, then come over in position, then drop
Right.
down vertically, and then.
No, I think for
out.
this one, we can just cut through that tiny bit of the wall. It's gonna be a press fit, and that wall is pretty much gonna be sandwiched between the two sides. So I've talked about this part with my team before, and just cutting through that wall that extends outwards is acceptable.
Yeah, what you could do is just put a clearance cut in there and just put a note on the print that says clearance cut optional, and just define it as a specific radius and a depth. And that way it allows the manufacturer to do whatever suits their machine best.
All right.
We're back to the same thing, tiny little corner radiuses, unspecified inside corner radii. I need to know what
Sure.
I can get away with. And these windows here are going to be very difficult to make once again because of the 20,000s radius. I would need a 40,000s end mill to go in here, a 1 millimeter end mill. I mean, if you can turn this into a full round, that would be nice.
I
the
don't
windows
think
before.
that would be possible because those these parts especially, these are pretty tight on the tolerances just with everything kind of going in together. So I'll have to double check on that.
Yeah, if you need it, you need it, and we'll
Figure out.
all right, we'll quote it appropriately
Yeah.
to the price.
Yeah, no, but I appreciate you bringing it up. It's something that I'll review and just double check.
Yep, cost driven.
Okay.
Once again, if the part can live with a tumble finish, we'd love to tumble all the parts just to give you a smoother finish. Now we'll go on to the last part, which is this multi-part assembly, which is a stamped part, which is really our
One of our.
wheelhouse.
Yeah.
Sure.
We're very good at stamping, but there are just a few areas of this that really are not stampable.
Mhm.
If I look at just the part itself, you cannot stamp a gap less than material thickness.
So actually, just for context, we plasma cut or laser cut this part and have it bent. We don't make enough to justify a full stamping die, essentially. So currently, the provider that we're using, we are cutting and bending, and not.
That was going to be my second option to you. I was curious about quantity going down in
Right.
the future.
Yeah, so this is our Gen 1. We are anticipating in the range of about 3,000 or so for the next year. They are big ticket items, so we don't rely on quantity as much as, say an Amazon Alexa or something like that. So that's our forecast for next year, about 3,000 to 4,000 pieces.
Then that's exactly how we're going to quote it, which was our second
Yeah.
option. So we will quote
Yeah.
you a laser cut blank and a form tool that will put in the nubs and the bent walls.
Perfect. And generally in the past, we've ordered in quantities of 1,000. So 3 orders through the year of 1,000 pieces. But if we could also have the option of like a 500 or a 200 quantity order, just to know, if we need a smaller quantity at any point of time, what would that come to?
All right.
I'm just looking at your tolerance.
It applies to all these pieces. And also, just so you guys know, everything that I've sent over is kind of a representation of the entire assembly. There is, however, only one of those stainless steel parts. There is only one of these rolled steel plasma cut and bent parts, but there are a number of the aluminum anodized parts. There are a couple more. They are not necessarily as complex as, say, the cone-shaped piece, but they're roughly, like the other part, the one that kind of looks like a spaceship.
Yeah.
One more thing to note, looking at the 037 part,
Sure.
the tolerance block
Yeah.
has angles at 1/4 degree. And that will be a rather immense cost driver. Trying to even measure something to 1/4 degree becomes very, very difficult.
Sure.
One of the only angles you have is the inside of the little round formed bumps at 40 degrees.
Mhm.
And the only way to measure that to within 1/4 degree is to cut it in half. And as soon as I cut it in half, I can't really measure it that tight anymore.
Sure.
So, I don't really believe you need it within 1/4 degree.
I will double check and have that
But
update on that.
giving us ±2 degrees would be great. I'll take ±1. Anything tighter than that becomes a cost driver.
Okay.
Well, I gotta look to see if there are any other angles on these prints. But that would be a common note across all the prints,
Sure.
any angles.
I will verify. The cone definitely does have some very strict angles. I mean, like I said, we're dealing with optics, and we've
Yeah,
got
if you need it, you need it. Absolutely. I will make that a common theme. I see there's another angle on the stamp on the laser cut part, which is 2x 50 degrees. So there is more than one angle, and having a laser, having to hold.
I would say that the laser cut part is the least precise out of all these. It doesn't deal with any of the optics, so I'll work on the tolerances on that particular part.
Okay.
Very good. And that's it. Those are basically our comments for the manufacturability of the part.
Perfect.
Looking forward to an email, new prints, new solid models, whatever you could give us.
Yeah.
Yeah, absolutely. And yeah, just send me a link to this recording. Aside from that, I wanted to ask, so do y'all have anodizing in-house, or do y'all partner with any companies nearby or anything like that?
Yeah, we have a bunch of partners, all local, all certified, that we
Okay.
routinely use for anything from, passivation to anodization and all kinds of other,
Great.
treatments or finishes. So
Okay.
yeah, that's something we can incorporate in our quoting when we get to that point.
Yeah, absolutely. I've listed the finishes and any of the required coatings or whatever on the drawings. Just one of them, the cone, it's a little unclear. I had a discussion recently with my colleague about this. We want the matte black finish. We don't want a polished, smooth finish on any of them. It's a little unclear. I think it references like a polished smooth. What we mean for the cone is that it just needs to be a uniform kind of. Let me turn this.
No,
Understood.
Yeah, it just needs to be a uniform matte black, because this external part of the cone is one, visible by our customers, and then two, the inside of it is actually where we have projector lights and our camera is looking into. So we want the minimal amount of like light diffusion within the cone itself.
Yep, so matte black, not a.
Right,
not a
you would,
polished.
Matte black and uniform across the surface.
what we've done in the past when finishes of either color or finish is critical, is we can ask for range samples. You know, we want 2 samples, one that's too shiny, one that's too flat, and you want something in
Right.
between.
Gotcha.
So there, we can work with our plater to make those samples,
Right,
and we would just make 3 sets of them, one for the plater, one for us, one for you, so we're
Okay.
all on the same page. So, but there's
Yep.
it won't be a problem at all maintaining that.
that
Gotcha.
sounds good.
All right. And do you guys offer ultrasonic cleaning in-house, like before, prior to shipping, or is that because right now our current supplier does not offer that? We clean them in-house. Ideally, we would like to take that off our hands and kind of move it to the supplier
Are we
side.
talking ultrasonic cleaning for these 4 parts or
Yes,
something
for
else?
the especially for the aluminum anodized parts.
Well, if we tumble them, you really don't need ultrasonic. When we tumble them, and if they get anodized, there's a chemical cleaning of the parts before anodized as well. So that just sort of comes along for the ride for free. So anything that gets
Yeah,
plated,
I mean, maybe we could evaluate that when we get to that step too. I mean, if we have to, we find a way, I guess, but
Yeah, because I mean, right currently we're still receiving the anodized parts, and we go through a cleaning cycle just to get any of the oils or anything like that off the parts, any dust and
yeah,
whatever it may be, just given that they're foreign optical assembly.
all right.
So just wanted to ask.
is the cage hook,
Mhm.
let's see,
I have a fake-
made out of 3/16 stainless.
Yeah, that's the only 316 stainless part, and this part that we're looking at right now is the only rolled steel part. The
it's
sheets,
aluminum.
everything else is going to be aluminum and
The
anodized.
passivation gives you that ultrasonic cleaning that you need too, so
Sure,
it's for free, comes along for the ride.
gotcha. All right. Well,
All right,
gentlemen, it's been a pleasure talking to you.
you
Been a
too.
good
Thank
pleasure.
you.
We'll talk to you soon.
Looking forward to hearing back your feedback there.
Absolutely.
All right,
Have a good day, sir.
thanks.
You too. Take care.